This is tutorial for boundary layer number 10. Figure 2 shows a flat plate 3 meters length here and 1.5 meter width is held in water moving at 5 meter per second parallel to its length. Determine the power required to overcome the drag. Here, so the question asks us to find what is the power, and the CD for lamina and CD for turbulent is given in this question. So means that you need to choose whether to use lamina or turbulent, or you need to consider both lamina and turbulent boundary layer. Similar with previous tutorial, first we need to calculate the Reynolds number. We found it is 1.5 times 10 by the power of 7. We could say that it is fully turbulent boundary layer. And then we need to check again what is the length of lamina boundary layers. And then we could get from this calculation, so the XL means the length of lamina boundary layer is around 0.1 meter. So compare with the total length of that flat plate, so we could say only 3.3% only lamina boundary layer, so means it can be neglected. So from the question, we use drag coefficient for turbulent. So it is equal to 0.074 over Reynolds number by the power 1 over 7. And then we substitute the value, and this is the value of drag coefficient. We could calculate the value of drag force here by using this equation, and the CD is the CD of turbulent that we get here, and the A is the area of that plate, which is 3 times 1.5 meter. So we get 152.4 newtons. But what we need to understand is, if we have a flat plate, we need to imagine that both sides will create boundary layer, will have boundary layer. So means that we need to multiply it into with 2, because we are calculating the total drag force that occur on that plate, not only for just one single surface. So we multiply into 2 with 2, so we get 304.8 Newton. But the question asks what is the power to overcome the drag. So the relationship between force and power is equal to drag times velocity. So we multiply 304.8 times 5 meter per second, so we get 1524 watts.